Well, so in this particular course, that is a the electromagnetic field theory and transmission lines. So in that we have completed the first half, that is electromagnetic field theory. So in 5 modules, we have discussed about electrostatics and electrodynamics. At the end, we have studied about wave equations and how the wave propagation takes place in the medium. And so that is actually, after that, some more topics also available. But considering the fact of the limited scope of time and the grade and everything, so they have reduced that. And just after that, so many things are available, like how different boundaries can be followed, like the concept of impedance. So many things are there. And very correctly, they have cut short the units also. So, mm, so then maybe just before the CAT 2 days, two classes, I will discuss about this summary of the last 3 modules, which are considered for CAT 2. So we will move to next module, that is the transmission line theory. So the module 6 and 7 discuss about the transmission lines, the theory of transmission lines. So I would like to give the introduction to this transmission line theory from the aspects of transmission line theory. And moreover, this particular concept is connected with other few more concepts, which possibly you can take it as an elective course, so that you will get some idea about how all the systems works. And you will wonder that the key important secret behind this so-called communication systems, and then some of the very important systems like radar, then many microscopes, microwaves, spectrographies, and then so many things actually highly connected with this particular topic. I would like to give some idea about this so that you will get the concepts of the other future courses. And in fact, without this, you can't say that you are a electronics and communication engineer. Yeah. So in fact, all the concepts and everything in communication systems, it all started with this 4 important equations. So this is why actually you can find in uh, some of the YouTube videos also, you can see that they have they have told like Maxwell is as compared as Newton and Einstein in the field of physics. It is one of the intelligent or the genius, we can say that. I have summarized the important equations. Moreover, the first 2 equations directly describe the relationship between this electric and magnetic fields and how they manifest each other, how without any support of any medium or anything, how they can create one and another. So this is one of the very interesting concepts. And there are some unsolved problems also available. Maybe you people can note down, and if you solve that problem, maybe there is a possibility that uh, you will become legend in that. In fact, I thought about this particular problem, that if we have a superconductor. So do you know what is meant by superconductor? Anyone say what is that? Any idea what is this superconductor means? Okay, superconductor is nothing but the one which has the infinite conductivity. And this is almost impossible with the practical world, but there are some possible aspects. We can go near to the infinite of very high value. The conductivity of the copper is around some 5 to 10 power 5 to 10 power 7 Siemens per meter square, I think, Siemens per meter. Yeah, but that value is so finite. So if we can bring very high value, this is possible by reducing the temperature in very close to zero, very close to 0 Kelvin, like millikelvin, like that. It is impossible to achieve 0 Kelvin, which contradicts the law of thermodynamics itself. It is almost impossible, and therefore the question of the existence of the material, everything will come into the picture. So when you reduce this to very, very low temperature, you could achieve the conductivity as very, very large value. In this particular case, there is a question will come that what about then if we have a coil of superconductor, this is completely superconducting material, and if we bring the magnet front and back, if you bring in, then obviously any conductor will produce uh, the induced EMF, which will be reflected across this. You can find the potential across that, and this is actually happening because of the induced EMF. That is always we can calculate by closed integration of this electric field into dl. And in that case, if it is having infinite one, and therefore we can argue that, and another important property of the superconductor is the electric field inside the conductor is always zero. So this is one of the very interesting property. In that case, if we place the superconductor, will there be any induced EMF or not? Because electric field is anyway going to be zero, and this is going to be the EMF. If the EMF is zero, then there won't be any potential produced, neither the current also. So in that case, whether the superconductor is this particular problem is meaningful or not. In fact, this particular question I had in 2010, 2011, like that. So I was searching what could be the answer for this, like that. But recently in YouTube, this particular video, one particular video released by one of the genius professors, 2, 3 professors, including Indian professor, Professor Verma also. You could think about how to solve that particular problem, and you could derive, because you have already studied all these set of equations, so possibly you can answer to such questions. Yeah, this is one particular problem. There are so many problems are there. In fact, Maxwell himself solved around some 150 problems, and out of that 150 problems, we could say that around some 10 maybe come into the picture, and among that, one of them is the existence of charge atoms and other things, and another one is the interface states, where you have studied MOSFET and BJT. All these semiconductors are coming into the picture. And then the other theories like wave propagation, all these things. Yeah, the Maxwell equations, one of the most contradicting concept is the displacement current. We already discussed about that. At the end of that, what we get is this. Whenever there is a time varying, if we will take a wire, whenever there is a time varying current is traveling in this, then this is having time dependent one. In that particular case, this always produce the displacement current, and this displacement current, which is going to flow outward direction, which will be equal to dou d by dou t. And so in this, I already told that this particular term is equal to frequency, the rate of change of the current itself, which directly manifests to field in this case. So if this is so, then whether we can prove it or not, this is already proven in a Hertz experiment. This very well proved, and you are having all mobile phone, everything works in this same way. So what is actually happening, that if we take a wire and if we send a time varying signal, so if we vary the signals, a time dependent signal when we give, that means we are giving some signal with frequency. The frequency is not equal to 0. In that particular case, naturally the electromagnetic field will start to come out, and that electric field and magnetic field both are actually time dependent ones, and immediately this will be available as a propagated field from this structure. So that is what we are saying is the wave propagation out of the wire. Alternatively, we can do by means of generating that charges or the current. That is by means of bending it. Instead of the wire in straight manner, if you can make it like a zigzag manner or in a uh, in different directions when you do, then along the space, along the z direction, you can see that the current actually get changed, and this creates the change in current, and because of this change in current, there is a production of the uh, radiation, or the electromagnetic radiation could be possible. And so that is what people used to say. In order to get high electromagnetic radiation, you have to do two things. One is you have to give time varying signal, and the second thing is you have to bend the wires in such a way that the radiation is fastened, or the rate of change of the current within the scope of wire is great. That means there will be escape of field components from the bend. So this is what the two things we are doing in any communication system. If you notice very properly, any communication system starts with the oscillator, and this is what we name it as a carrier frequency. So this carrier frequency is going to be utilized in different paths. Maybe we will multiply with the in-phase component, out of phase component, and uh, we will we will mix with the information signal, which is a low frequency signal. We can say this is the signal which has the information, and that will go to the antenna. Uh, that could be a question, that why can't we use a square waveform, a very low frequency? Why people use this very high frequency? You could see that the 2G mobile phones, they are using 800 to 950 megahertz. Bluetooth uses 2.45 gigahertz, and 4G communication is approximately about 5.5, 3.1, like these very high frequencies they are utilizing. So in this particular case, why this frequencies keep on increasing? The reason is this: by increasing this frequency, you will get better radiation. If there is a better radiation, it is very enough, or very less power is sufficient to uh, get it, and therefore the gadget size will become very small. You could notice that the olden day mobile phones and nowadays mobile phones, the size and weight, battery power, everything else, you could notice the difference. So this is why actually people moving towards high frequency. So the 5G could be operating more than 30 gigahertz. The planned one is 32 gigahertz, even 27 gigahertz also they have recommended for 5G applications. So this is, and this theory, by and the concept of introducing the time varying signal, and by bending the wires or taking different shapes, and this is what the whole idea about this antenna theory. And this, any structure, if you notice any antenna in your life, you will see that they won't be in any proper shape. They will be having different shapes. They will be having, say, it will go like that, and there will be a structure, and there will be some supporting structures like that. These all structures are used to make the radiation better. And maybe when you study the antenna theory much more in detail, you will understand. The very important question for all the EC student is, why I have to study antenna theory? Why I have to study? Because it is an elective course, like I have to study. The very important reason is very funful one. The thing is, if you notice any electronics related courses, if you take this triple E, and then E&I, and then even computer science, or what, and you take any course in engineering, you will see that there are two courses. One is this antenna theory, and the microengineering, and this transmission line theory. These three courses will not be taught to any student. This is actually only, these are the three courses only taught for EC students, because these are the founding structures of the communication engineering. So that is why only communication engineering students used to study that. And in other words, we can say that if a EC student don't study these courses, they are not at all EC students. They are simply nothing but the other type of students. Okay, so you have to keep this in mind, and maybe when you study this course, you will understand how far this is important. So that is why I'm giving some introduction for it. By by preparing this, if you take a normal wire, two-wire system, and if you start to bend it, and it start to radiate, so the time varying signal whichever is getting in, it will get alternate field components. One field component will be this way, the other component field will be the other way, and by doing so, so for example, every time at time t equal to t by 2 and after t by 2 at time t, you could see that this field components, they in order to maintain the equilibrium, they couple each other or loop each other, and they can start to propagate. And so this is how the simple two-wire system can radiate the signal. And this is one of the very famous antenna called a dipole antenna. What we have done is we have taken two wires just perpendicular to each other. So you could notice that whenever there is a time varying signal goes in, so one will be positive, the another one will be negative. Interestingly, what will happen? This positive signal, when it is having the current like this, the negative also will be having current like this. So these two currents, they are going to make the radiation in a particular direction. So like this, the wave will start to propagate. And you have studied about how this wave can propagate in a free space or in a different medium, how it can propagate. So this is how the electromagnetic radiation happens in a wire. And by developing this idea, people have come up with so many different types of antenna. What you are seeing is the very few antenna systems. And what you see here is the dipole antenna, what we have studied. Another one is by setting up loop, we can get loop antennas. We can get helical shapes structure, which for helix antenna. And we can get the antenna using PCBs. Like it is meant for like compact wireless applications like mobile phones, Bluetooth, dongle, all these things. And you could see this particular antenna. This one is very famous antenna. Maybe when you draw any home, people always draw with one particular antenna like this. So this antenna called Yagi-Uda antenna, one of the historical antenna. And this antenna has some interesting property, maybe when you study that. And very, very high power systems for dish antennas and all. We are having different shapes. So many different antennas are available. These antennas, one way or other, you will always use throughout your life. And I told that why you have to study this antenna course. That is one particular reason is because all EC students supposed to study. The next important one is in future there won't be any wire between two communication system. You will always see that the wire, everything will be connected by wire. Nowadays you can notice that the chip to chip communication, for between two chips we uses wires. Can anyone say what these wires are called? In microprocessors they used to call this by a name. Between two chips they put set of wires. Anybody has idea about that? So they are called bus. Okay, so these are going to carry the signal, and in future, considering this in a PCB board, you can see that the chips will come here, and in the bottom also chips are going to come. So in order to communicate this to this chip, they are going to use wireless systems with terahertz frequencies. So this is called wireless interchip communication like that. So in that case, every chip will be having one antenna. So in antenna is going to be inevitable structure in almost all the systems. In future, there are body planted communication systems are going to come. Some personal devices, for example, if I touch, it will work like that. So in that particular case, antenna is going to be inevitable one. So always there will be an antenna engineer requirement will be there. You could notice we simply put Facebook antenna engineer like that around some. Even I have seen all the years Facebook open for antenna engineer. You could wonder that Facebook is kind of a website company. They are running out some social media site or something, but why they have to recruit antenna engineer? Because there is a possibility that they will recruit, they are going to construct their own mobile phones or some sort of communication systems or some kind of wireless servers here and there. So in that case, this antenna engineer is going to be one of the future job. So, and so this is actually one particular topic. Alternatively, the question of the concept of the transmission line will come. Therefore, what is meant by a transmission line? So the transmission line is nothing but any particular structure which carry the signal within a scope of the particular structure. For instance, here what you see here is a two-wire system. So if you take a two-wire, and I am going to give a oscillator which will be connected to this positive and negative like that, then the field will be available within this two. So it will travel in a sinusoidal manner. So whenever it is a positive one, and whenever negative half cycle, positive half cycle like that, it will be keep on propagating within the wire, and they are often named as the guided lines, because these lines are going to guide the wave propagation. So we have studied that how the wave will propagate in different medium. Similarly, in these kind of guided medium, if it is there, how this wave will propagate. And in this propagation, we can model this entire transmission line as a RLC equivalent. So this is the very first step you will see in the transmission line theory. First, we will convert this transmission line into this sort of RLC equations. What is the advantage of RLC equation is we can easily solve with many of the fundamental circuit theory like Kirchhoff's law and other simple transmission circuit theory we can utilize to get it. And we will map this all transmission lines into length of lines. So there always you will see length of line and the impedance. We have studied wave impedance. Here you will see transmission lines will be having their own impedances. So these two are linked and mapped in a circles. They are called complex circles, and that is created by Philip Smith. So that is why these charts are called the Smith chart. And the interesting thing is only easy students can understand what is this Smith chart and everything, and no other student cannot understand in any other discipline. So we will see how the Smith chart comes into the picture, and we will see different types of transmission lines. One of the famous one what you have seen already is the coaxial cable. Coaxial cable, you have seen one type of this one in the labs. These big, as the size goes bigger and bigger, their operating frequency will be, there is a frequency called cutoff frequency that will be limited to low frequencies. So these frequencies we can construct with the different types of coaxial cables for different applications. So for instance, when you see the so-called base stations, the mobile base stations, you will see that there are black color thick wires will be running. Inside that you can see that there are so many transmission lines will be there. Each and everything will carry different channels for different antennas in the top. And this is very famous one, and people use this kind of waveguides, and these are nothing but hollow metallic tubes, and inside that the wave can travel, and this is the very first of the transmission line concepts evolved with that. So these are called waveguides. The waveguides largely used for high power applications. And we have low power transmission lines. They are made up of PCB boards. So we will take a substrate. This substrate will be nothing but some polymer material, will be having its own dielectric constant. By placing two wires, that means thin films, top and bottom, we can control the electric field and magnetic field, everything. And by that we can construct some structures. So here when you take the cross section, you will see this type of structure. So you can see this is what the top view. So this top view, when you see that, this is what you are seeing, this is the transmission line. They will travel within that, and here we have some electronic circuits and other things. This is simply a microwave amplifier which operates at I think 4.1 gigahertz. So here this kind of circuits we will see. So not a normal wire. These are nothing but wires of high frequency systems which are carrying very high frequency signals within this within the scope of the boundary conditions what we have referred for the reflection and refraction all the way. So that is what we call guided lines, and we have so many guided lines or transmission lines, and not only this, actually different types of transmission lines also available. So for instance, if you see this, this is actually the one the receiver for the Hubble telescope, which uses very high diameter of large diameter of a dish, so that the signal will come from satellites, and they all will be scoped to this, and further it will be going down, and here this power will be very large. This power will be around some 1 or 2 kilowatts power will come. So they will be reflected inside, and they will be coming through this waveguide system. Finally, at this particular, the entire carrier separations and everything will be done this kind of waveguide systems. So you can see that many tubes are available, black color tubes, and different bends and everything. They are all nothing but waveguides. Inside that, very high power microwave signals are traveling. In order to handle very high frequencies, we need this type of transmission lines. And so in order to design such a transmission line circuitry, we need such a transmission line theory. So that is what we are going to study. So out of this, what are the other benefits we have? We can construct the entire communication system with this transmission lines. For instance, what you see here is the Qpsk modulator. I believe all of you know about this Qpsk modulator at this particular time. Maybe you are second year or third year. So in the digital communication, this will come. Okay, so you have an oscillator. This oscillator will separate the power into two. So this is the carrier signal. So this carrier signal will be given to two information. One is one type of binary data, another type of binary data. These two data will be low frequencies. I will call this as FL. Okay. So this low frequency and high frequency, they will be mixed. And this mixed signal will be given so that simultaneously in one particular symbol or one particular signal, let's say you have the signal like this. So some kind of signal. So within that you can store both the bits 0 and 1, 2 bits you can store. And so this is called one symbol. So this symbol will be transmitted through antenna, and at the receiver location also we do the same action in the reverse way, which we call demodulation. In this, the entire all these systems, from if you take any particular system, everything can be constructed using this type of transmission lines. With this type of transmission lines we can construct. So for instance, if we take a low pass filter, so we know what is low pass filter, that up to particular frequency it will allow, which we call pass band, and remaining all frequencies will be stopped. So that is why it is called stop band. These are defined by means of a cutoff frequency calculated with respect to the gain of the low pass filter. So gain of the low pass filter is calculated for the input voltage, what is the output voltage over the frequency. So this ratio V0 by V out by V in is nothing but the gain. So the gain, and when you draw the 3 dB, you will get that cutoff frequency. This is normally people used to design with very simple idea that if you take a RC shunt, then you will get low pass filter. Very quickly you can calculate the low pass filter. You have the RC, so take the cutoff frequency is nothing but 1 by 2 pi root RC. And if you know the capacitance value, you can calculate the resistance, or vice versa you can do. So by substituting this RC in a continuous, in a periodic manner, you will get this low pass filter, and the low pass filter will clip off this region. This region will be allowed like that. But the problem with this kind of lumped elements, the lumped capacitors and resistors, they have a problem that at very high frequencies, very high frequencies, they lose their properties. You can see that this is one of the aluminum oxide capacitor. At low frequency at 100 kilohertz, it show very high capacitance, but at frequency goes increase at gigahertz, where the microwave signals they are actually going on, and they lose their properties. So constructing low pass filter with a lumped element where the inductor capacitors which are coming, they can't do the justice, or in high frequencies they tend to give poor response, or the cutoff frequency may be shifted, or so many things could happen. But rather all these capacitors can be converted into transmission lines. What you see here is the inductor and the capacitor can be converted into transmission lines. Whatever you see here is nothing but all of them are transmission lines. By converting this some steps which you will study in the microengineering, you can construct a low pass filter like this. Many people won't believe that this is a low pass filter, and this low pass filter will give this kind of gain response. So you can see that this is the lumped element based low pass filter response. At stop band, you can see that they are showing some, still allowing some signal, but this type of transmission line based, often referred as distributed elements, so they are showing very sharp cutoff. So this is why for high frequency applications, this type of transmission line based circuits are preferred. So using this transmission line based circuit, you can construct the entire circuit itself. What you see here is nothing but a Bluetooth system, and which is having so many things like filters, then couplers, so many things that we can construct with this simple transmission lines itself. There is no capacitor, inductors, not at all required, and that is why I always say that this is equal to this the transmission line based. So there are so many other benefits are available, and you can construct here. What you see here is nothing but the entire RF front end, which is actually fabricated on the PCB itself. So, and another very important application is this kind of inductor is very, very difficult to develop in very, very high frequencies, and capacitors sizes will become very, very small, and you can't even integrate with the existing systems. But the advantage of this kind of transmission lines is you can choose the length of the transmission line to achieve a particular capacitance value or inductor value. By this, you can construct any communication system. The entire communication system can be designed. And for example, you can see here Bluetooth receiver and mobile. This is actually the entire mobile phone structure, and this automotive radars and everything else can be constructed with the same theory of the transmission line concepts. And such a development is often referred as microengineering. So that is what the microengineering. So this is how these all theories are connected. First, you will study the electromagnetic field theory, and then you will study transmission line theory. Then from this, people used to study microwave engineering. And alternatively, you could notice that there is a distinct difference between the transmission lines. The transmission line always will be always will go within the wires, but antenna is just opposite that. It will simply radiate out of the wire. So we can say that the antenna theory and the transmission line theory, they are actually complementary to each other. So its complementary is nothing but the antenna theory. So here also microengineering can be somehow influencing this particular antenna structures. So by this way, the communication takes place in two possible ways. One is actually wired, another one is wireless, but both are highly important. For instance, in order to transmit the signal from very, very for high power applications, so far now there is no wireless system being developed. Do you know anyone that for why high power applications like for satellite applications and other things and all, why still people are preferring wired? When the high frequency signals are coming out of the antenna, they tend to ionize the nearby particles like air, medium, water vapor, everything. They heat up it. So that is what happening inside this microwave one. So such a phenomena can happen even at certain level when the power level exceeds more than some kilowatts power or something within 1 kilometer radius itself. there is a possibility that the human skin can be heated up. There is a mild sensations can be, and at high frequency, as I told, that the flux density will be very, very high. So there is a further problems could happen. So that is why people are afraid of this 5G systems. But there is no problem. These 5G systems are going to be utilized for very, very close applications. For instance, every street will be having one base station. So this street will be having one base station. So the total transmission distance will be in terms of meters will come, not in kilometers, in meters it will come. So these all will be connected by means of very high frequency wires or terahertz signals, which won't create any problem for the human being. So this is what the three theories after the after this electromagnetic field theory. So first you will study about the transmission line theory, and then you will study antenna theory, then you will study how to integrate this wired systems by means of microengineering. So these all theories are very essential theories to develop the entire communication system. Your mobile phone is working not because of any Android app or anything else. Your internet, everything works because of this kind of microwave systems, and which are developed by RF and micro engineers, and they are few in number, but their, their application is very huge. Almost every human being has one mobile phone. So in future also, the demand for many wireless systems, very high frequency systems will come. So this is a great opportunity. If you choose your field towards this microengineering, then you will be one of the unique, and you cannot be replaced. Such a other like other software engineers can be replaced, but micro engineer in a system cannot be replaced. So, and if you enter as a fresher, within 10 years your salary will be very huge. So like many people used to say, the RF engineer salary will be as good as this president of India, like that. So you can develop if this one rare opportunity as a EC student, and you can utilize the same systems for many of the biomedical applications. Maybe I will cover up that particular part in right, because recently we have started to study how antenna influencing our human body. Particularly, we are using mobile phones near to our ear, brain, and mouth, and some important glands also available. How these are affected because of electromagnetic radiations, and how we can avoid that. It is very simple that if you use, this is the mobile phone, and your camera and your antenna, everything will be available here, and your earphone will be here. Your speaker is here, your earphone is here, something like that. So your human body will come here. So there is a possibility of radiation in all the directions. So we can reduce that by means of placing some interesting surfaces called frequency selective surfaces. We can reduce that. In fact, we are working in that particular regard, so, which is very mild with, and so in future so many things will going to happen. So we are actually working various research works we are actually. So if you are much interested in this concepts, maybe you can approach us, and we will help you to develop these kind of interesting communication block sets. This the simple introduction I am giving. So soon we will go to the transmission line equations, which will be very similar to that of this wave propagation, where you will study this alpha, beta, attenuation constant, phase constants, all these things will come. Then you will write the expression for the wave impedance of the transmission line, which is often referred as characteristics impedance. Then we will study this phase constant, all these group velocity, whichever we have studied very recently for a wave propagation, all these things we will study, and this will be a little bit different, that's all. Then you will once again study about losses and losslessness, all these things, and directly we can convert this into equivalent circuits will come. There some after that it always look like a circuit theory. You can easily do some simple circuit theory work to construct simple systems, and complex circuits like this also can be created. This kind of complex circuits also can be created with the system, and I felt like even in my BTech itself, I felt these theories are very, very exciting. And so I have chosen this particular field. Microengineering is my passion. So that is how I have grown up over the last 15 years, I think. Yeah, more than 15 years I am in this field. So if you're interested, you can approach me. Not only me, so many people are there. Nearly about 15 faculty members are there in VIT, working in the same field of microengineering itself. So based on your interest, I will tell you who is the